All right, so hi guys, welcome. We are going to be doing our doodle notes on density. They should be the next notes in your page if you're following along, doing everything daily like you should be. We're going to start off with this very top box right here of notes. So density, actually we're going to start right here, is defined as the degree of compactness. I know that doesn't mean quite so much to you right now, but density really helps us determine how much matter is in an object. So, or how much matter. A really dense object will have a lot of matter, will be really compact. That means the molecules will be really spaced, will be really close together. So let's draw that. A really dense object will have, if these dots are molecules, the box is the boundary of the object. Our molecules will be really packed in there, nice and tight. If we have an object that is less dense, it's not going to have nearly as many molecules. There'll be lots of space. Therefore, it won't be as compact. Okay, now we're going to go over here to a combination of units. Remember, doodle notes we color, so you're going to color these in right here. You don't have to watch me color, so I will finish coloring later, but you are expected to at least color in the bubbles. Here we go. Derived units, they're a combination of grams and milliliters. Milliliters will be on the bottom. Also, for our volume, when we measure, so it's pretty important to know that density is, use some different colors for this. Mass, started writing cursive, which we typically measure in grams, over volume, which we typically measure in milliliters, but 1 centimeter cubed is 1 milliliter. We get that because the formula for value is length times length times length, or centimeter times centimeter times centimeter is a centimeter cubed. Okay, so typically our units are going to be grams per milliliter. We get that from this equation right here itself for our density. Density is going to help us understand the currents of the hydrosphere a little bit more, which is why I really needed you to understand kind of what density is, where do we get it from in terms of formulas and all that stuff. So an object that is less dense will float. We're going to write that down here in a second. Sorry, I'm working on my coloring. If I drew for you a simple glass of water, and leave yourself some room because you've got 1, 2, I believe 3, possibly 4 practice problems, so I can't remember. So you're going to draw over here. So we have a glass of water. Here's my glass of water. And we're going to drop a rock in my glass of water. Isn't that a beautiful rock? We're going to have to label it rock. Rock. And we're also going to have liquid water. And we're also going to have some ice. Now, ice generally floats on top of water. Or you can even think of this as, maybe we won't call it ice, maybe we'll call it styrofoam. Spelling of that might be off, but let's say it's styrofoam, like pieces of styrofoam cup. So the pieces of styrofoam cup, if I compare them to the water, the styrofoam cup is less dense than water. We know this because, or our evidence is, it floats. So we know it's less dense because it floats. In contrast, our rock is more dense than water because, or our evidence for, it sinks. Now, this is really important as we get to start studying the different ocean currents, because density differences in water due to salt and temperature, we're going to find out, is actually what causes the ocean currents. So it's really important that we understand this scientific phenomenon or measurement of density. So we've got a couple of practice problems to do together right here. Then you've got a couple more to do on your own. You'll do them right here. They're on Canvas for you. You'll do them right there. They're on Canvas for you. Make sure you have this drawing. Remember, we know that styrofoam is less dense than water because it floats, and we know that the rock is more dense than water because it sinks. Okay? So let's go over here to this practice problem. An object has a mass of 20 grams and a volume of 10 centimeters cubed. I just recalled that it would be best for me to my friend just, her cat ate her plant, which is sad because I gave her the plant, but that's okay. Okay, an object has a mass of 20 grams. Our problem told us that the mass is 20 grams. And we know, oops, this would have helped if I was writing in the color-coded colors, but we'll do that in a second. And we know from our problem that our volume is 10 centimeters cubed, which we also learned a centimeter cube is the same thing as a milliliter. You ever heard doctors say 3 cc's? That is centimeters cubed. It's a unit of measure, right, for volume. And to find the density, we know that it is mass over volume, so we will take 20 grams over 10 centimeters cubed. That comes out to 2 grams per centimeter cubed. Let's make sure my math is right. Yep, I'm a genius, I knew it. 2 grams per centimeter cubed, or grams per milliliter. Okay, there's your first problem. Next problem, an object has a volume of 55 milliliters. So we know our volume right here is 55 milliliters. And a density of 5 grams. Or 5 grams per milliliter. So our question is, what is the mass? So we're going to set this up so we know that density, 5 grams per milliliter, equals mass over volume 55 milliliters. To get the 55 on the other side, we must multiply, because we're dividing here, so we must multiply 55 milliliters, which cancels these out, by 55 milliliters. And 5 times 55 is 275 grams equals our mass. See, you do remember to get something on the other side, you do the opposite of what's happening. So this was dividing, so we needed to multiply. If we were multiplying, we would have divided. And lastly, an object with a length of 30.2 centimeters on all sides has a density of 62 grams per centimeter. What is the mass? So we know that our density is Our density is 62 grams per centimeter cubed. We weren't given volume, but we were given length. Length equals 30.2 centimeters. If we go back to our equation right here, volume is length times length times length. So that would mean that volume equals 30.2 centimeters times 30.2 centimeters times 30.2 centimeters. Or, let's do the math real quick. 30.2 times 30.2 times equals 27,543 we'll go with 6 centimeters cubed. And we know our density. So our density, so now we have volume, 27,543.6. So 62 grams per centimeter cubed equals mass over 27,543.6 centimeters cubed. Remember, we must multiply to get it on the other side because we want to solve for mass. We're multiplying by 27,543.6 on both sides. So this has canceled out. Mass is by itself. Let's go ahead and multiply that by 62. And our mass comes out to be 1,707,703.7 grams. So we have just solved for mass. All right, do the practice problems on your own. Once you've completed those, you are all good for today. Have a good one, guys.